Now we go to the second application. That is by using dy dx, you can determine whether the graph is increasing or decreasing. So increasing means the graph going up like this way. Okay, going up this way from kiri to kanan. Decreasing means the graph going down this way. Okay, this is increasing, this is decreasing. Okay, so for example, the x cube, the graph is like this. Okay, means the whole graph is going up from left to right. So this graph is increasing function. Then decreasing function is like this. Negative f cube. So from left to right, the whole graph going down. Okay, so increasing function, decreasing function. But some of the function, separoh increasing, separoh decreasing. For example, like this. Okay, so this one U-shape. Okay, on the left hand side, the graph decreasing. Then start from this point, the graph increasing. They'll change. Okay, and so on. So, okay, now we go to the nota dulu. If a function is an increasing function, that just now was the diagram. Using the diagram, you can see the function is increasing or decreasing. Now by using calculation, by using calculation, you differentiate the graph. If the derivative of the function is greater than 0 for all the domain, means the function is increasing, like x cubed. If you differentiate the graph and the domain of the graph is less than 0, okay, for all the value of x, then this function is decreasing. This is example like this one. Okay, this one when you differentiate. Okay, so the other one is this one. Okay, the whole graph is increased, the whole graph is decreased. Then number 2, if fx is increasing in certain interval only, then when you differentiate, the function will increase at certain interval, decrease at certain interval. This is, for example, like this. Okay. Okay, certain interval means on the left-hand side, the interval is decreasing, the right-hand side is increasing. Separoh sahaja. Okay, so then number 3, the change of increasing and decreasing intervals of a function can be used to determine the extremum point. Extremum point means maximum point or minimum point. That is extremum point. Okay, when we say extremum point means either maximum or minimum. For example, this one. Okay, when we move from left-hand side, decrease, then after that, initially it's decrease, then after that change to increase. So this point of changing here, the point, then it is extremum point, either minimum. In this case, it is minimum now. So another example is, okay, N shape. Initially is increasing. Then after that, this point, your graph will go down, change to decreasing already. So the change of increasing or decreasing, then from there you can identify the extremum point. So in this case, this one is maximum point. In this case, this one is minimum point. Okay, this is the meaning. So we are going to make use of increasing and decreasing to determine the point, whether it is maximum point or minimum point. Then number 4, if fx is continuous and changes for its increasing to decreasing, then it is maximum, local maximum, like this one. The important thing is this point must be continuous. Okay, if not continuous, then cannot. If not continuous, let's say, okay, let's say for example, if not continuous, okay, so this one is increasing. Change to this one is decreasing, but this point is not in continuous. Okay, so in case not continuous, even though the graph increasing change to decreasing, then it is not extremum point. So the sharat is fx must be continuous. Okay. Okay, why we say local? Local means when you have a graph like this, okay, local maximum point means this point compared with the point di tepi-tepinya. This is the maximum point. So we call it as local. Then, for example, this one also local maximum point because this point compared with the point di tepi-tepinya, this is the maximum. So we call it as local. So this one also local maximum point. Okay. Then this one is local minimum because this point compared with the point that near to this point, this is the minimum. This is the local minimum. This is the local minimum. Then for the whole graph, the maximum point, whole graph, the maximum point is this one. So this is a maximum point for the whole graph. This is the minimum point for the whole graph. Depends on if your graph is like this. Okay, so this is maximum graph, meaning the whole graph is minimum already. So if your graph is like this, so paling sikit punya, this is minimum. Paling banyak, this is for when you compare the whole graph lah. But for this one, when you compare with whole graph, this is maximum. This is so that's why. But normally we are interested in local maximum, local minimum. This one. Seldom we are interested at the end. Okay, so that's why you have the word local. And this one also the same thing. In case minimum, make sure the function is continuous. If the function is not continuous, then even though the function change from increase to decrease, then that is not local extremum. Okay, now we go to the example. All right. So it is given that the function here show that the function f is an decreasing function. Show that means you have to use the algebra method lah, using the calculation. So it means if you want to show decreasing, you differentiate first. When you differentiate, you get this one. Then you got to see, when you look at here, find the domain, look at this domain. This graph is negative. So because this is negative, what? For all the value of x, okay? Whatever value of x you substitute here, x kuasa 2 is a positive, but because of in front you have a negative, means for all the value of x, the f prime is less than 0. So you give the reason, for all value of x, fx is less than 0. Give reason why you say that decreasing. So the reason is this one. Okay, so therefore you say that this function is decreasing, selalu decreasing. Okay, or if you look at the graph, you can see already. The graph is like that. The graph is like that. So the tangent is like it. This is a tangent. Tangent always this tangent. So you see all the tangent will be always this way. Okay, dari sini ke sini, dari sini ke sini. The tangent selalu turun ke bawah. From left to right. So the whole graph is decreasing. Now number 2, this is simple one. I just show you the concept. Then you're given this one. for x greater than 0. Show that this is increasing. So same thing, you differentiate, you get this one first. Then, since you are given x is greater than 0, because square root what? Okay, so for all the x greater than 0, the whole differentiation is greater than 0. So means, so you have to show this one greater than 0. This one. Okay, when you write this one means you show the reason already. So since the derivative always greater than 0 for x given in the domain, that means this function is increasing function. So you can double check from the graph here. Okay, so when you double check from the graph, you see the tangent here, the tangent at this point, the tangent at this point, the tangent at this point. You see all the tangent are going up. Okay, so dengan itu conclusion, the whole function is increasing function. Okay, then number 3. Given that you have this function, determine the interval of increasing and decreasing of the function, hence state the local extremum. So means, okay, first you are asked to find the increasing, decreasing interval. Increasing means what you should do, class. You should find differentiation. Yes, since you're given fx, so you use f prime. Use the symbol same as the question. If the question give you fx, then don't use dy dx lah. Okay? If the symbol, if the question use y, then you use y lah. Okay? Unless you assign, you give a statement, let y equals x power 4 minus x, then only you continue dy dx. Okay? If not, you don't directly give dy dx because the question gives you fx. If you want to use dy dx, you bucket definition, you define, then only you continue with dy dx. Okay, now if I use the symbol given, I use f prime. So I differentiate, then I'll give this one. Okay, now you want to find the increasing, one by one you find. Now first I want to find the increasing of interval. Just now example 1 and example 2 is the whole function increase, the whole function decrease. But this question number 3, certain interval increase, certain interval decrease only. So now let's say I want to find the interval which is increase. So I have to put the derivative greater than 0. So means 4x power 3 minus 16x greater than 0. Then from here you solve the inequality. How to solve the inequality, class? We'll go back to SEM 1. Okay, so that's why all the SEM 1s are the basic of SEM 2 and SEM 3. So SEM 1 is very important. SEM 1 content is basic of SEM 2 and SEM 3. Okay, so but this is very simple because x you can take out. When x you take out means you will get quadratic. Then quadratic you factorize one more time. So the whole thing you factorize. Then by using the number line, then you get the inequality. How do you find this one, the answer? This one will go back to same one lah. Okay, go back to same one. You have 0, you have -2, okay, 2. Since this function is positive function quantity, so your graph is like this. So I'll go back to same one. And we want greater than 0. Atas. Okay. So means the interval is from -2 up to 0, then greater than 2, and not include the point. Not included the point because of this one. Okay, no, because of this one. Okay, then after that you give your answer. Answer the question. Don't leave your answer like this, Okay, therefore fx is increasing in the interval this one to this one, and this one to infinity. Please answer the question. Don't leave your answer in set notation. Okay. Then when you come to decreasing, you repeat the same thing. Don't say that, okay, I use the diagram just now on top is greater than, then below is less than. I directly give the answer. No, you have to repeat all these steps. Okay, already given a warning by the examiner. They said that you have to show the working step one more time, even though you see the working step is exactly the same, but repeat. So same thing, when fx is decreasing, f prime is less than 0, then you repeat. Again, you use this one, then you get. So x less than bawah, then x less than negative 1/2. X is from 0 to 2. Then you get this set notation, then finally answer the question. Okay, then you have answered the first part. Okay, then hence means use the answer just now to find the local extremum. Local extremum means can be local maximum, can be local minimum. Means if you want to find maximum point, minimum point during STPM time, you have learned you use dy dx, what, yes or not? Dy dx, you make it equal to 0, then you calculate, then that is maximum point, minimum point. But this question, you cannot do that because first you are asked to find interval, then hence find the maximum point, minimum point. Means you are not allowed to use dy dx to find the maximum point, minimum point. Use the change of increasing and decreasing method to find the maximum, minimum point. So now you list down all the interval you have got just now according to the susunan. So just now you have 4 intervals as well. You susun ikut dia punya susunan. First on the left hand side must be this one. Okay, then followed by -2 up to 0. You take from here. Then followed by 0 up to 2. You take from here. Then follow from 2 up to. Okay, first you arrange all the interval in one line so that you can see. Okay, so that you can see. So means so this is -2. This is 0. This is 2. Okay, so this is the interval. This is the interval of second. This is third interval. This is fourth interval. Okay, now by comparing the change of the function, okay, since just now when you calculate f prime, change the increasing and decreasing of the function, that is f prime. So when you calculate f prime just now, less than -2, it is -1, negative what? So right here, negative. Either you want to write less than 0 or negative also can. Okay, this is negative. Then just now, -2 up to 0, this is positive. And this is positive. Then from 0 to 2, just now this one is negative. And this one is positive. Okay, now you compare. Okay, negative means the slope is going down. Positive, the slope is going up. Then you sketch this one to show this one is the working step. Diagram can be considered as the working step. Now this is your working step lah. Okay, then okay, one by one. Now you have 3 critical points. One by one you look at. Now first you look at -2. So at the diagram, at this -2, you'll find that the slope changed from negative up to positive. Got changes. So means you must give the reason. In your module, I didn't give reason. So you just tambah. When you give when you make any conclusion, better you give reason. So means this one from negative change to positive. So that's why this is from negative slope change to positive slope. So you see here the change is like that. Okay, so it is a minimum point. So the reason is the function change from decreasing to increasing. This is minimum point. But the question asks for the point. The question asks for the point means your final answer must be in point form. So in case it is in point form, you must know the x and y. So that's why here I need to calculate the value of y. So finally, you mentioned that this point, -2, -14 is a minimum point, like that. Okay. Then when you come to x equal to 0, then you calculate, you find that y is 2. Then you investigate the change of increasing, decreasing. At this point, the function initially on the left-hand side is increasing. Then after the point, change to decreasing. So means got changes. So now the reason is this one. The reason is fx changed from increasing to decreasing. So that's why this point is a maximum point. Locker lah, you put a word locker there. Locker minimum point, locker maximum point. Okay, same thing go to x is equal to 2. Okay, so first you calculate the y, then you look at the change of the function. All right, x equals to 2. So after that, you give reason. Since the function changed from decreasing to increasing, then that is a minimum. That's it. Now we go to continue. Concavity and inflection point. Okay. When you study increasing, decreasing, dia punya main objective is to help you to identify maximum point or minimum point. Like this. That's why you study increasing interval, decreasing interval. Now, for this one, we want to identify how to identify inflection point. You have another point what? So during STPM time, you have learned 3 kinds of point. One is maximum point, one is minimum point, one is inflection point, yes or not? So by study increasing, decreasing, we can determine maximum point, minimum point. Now how about inflection point? So inflection point is related to concavity. Okay, locker maximum, locker minimum is related with increasing, decreasing. So that is just now. Now we go to inflection point. Inflection point is related with concavity. What is the meaning of concavity? Okay, concavity got 2 types of concavity. One is concave upwards, one is concave downwards. Like this. Okay, we go to concave upwards. Okay, concave upwards, the shape of the curve is slightly same as a bow, like this one. Like this. Concave upward means the shape is likely same as a bow going up. Concave downward means the shape is likely same as a bow going down. U shape, M shape lah, generally. Okay, U shape is concave upward, N shape is concave downward. Okay, so this is by using diagram. But concave upward, a bow, you see, a bow. Actually, you can separate into half. One half is this one. The other half is this one. So even though half sparrow sahaja, but this is 1/4 actually. 1/4. Let's say, imagine one circle. Okay, one circle. Okay, then quadrant. You see the quadrant. This quadrant facing up. This one can be considered as concave upward. This another quadrant also facing up. So concave upward. But on top of this quadrant is facing down. This is concave downward. Another quadrant, this is concave downward. So you have 2 kinds of concave downward, 2 kinds of concave upward. Okay. So how do you differentiate? By using diagram. Nanti calculation, by using calculation, I explain. Okay, now by using diagram. Okay, so concave upward got 2 types. One is this one. one is the other one. This is concave upward. Okay, how to differentiate these two types? Okay, this type of concave upward, all the gradient of the curve is negative. So you see when you draw a gradient at this point, all the gradient, see, all the gradient is negative going down. So this kind of concave upward, we call this as negative concave upward. As for this one, see all the gradients going up, going up, going up. So this one is positive gradient concave upward. Positive gradient concave. This one positive, a negative gradient concave upward. Yeah. Okay. Now we look at the concave downward. Okay, concave downward, one quadrant, two quadrant. So this one, you look at the gradient line. Okay, going up. And this one is the positive gradient concave downward. As for this one, all the gradient going down from left to right. No? Okay, so this one is negative gradient concave downward. Okay, so there are 4 4 jenis. Okay, so this one is by using diagram. Now by using calculation. All right, by using calculation for concave upwards is d2y dx square greater than 0. Okay, when you calculate d2y dx square greater than 0, you only know the curve is concave upward. You will not, you do not know whether it's negative concave upward or positive concave upward. If you want to know it is positive concave upward, negative concave upward, you need to compare the dy dx. Tengok dua-dua sekali. Then only you can identify it is negative concave upward or negative concave upward. If you cuma tengok d2y dx square sahaja, you can only know that they are upward only. You do not know whether it is positive or negative. Okay. Then same thing for concave downward, d2y dx square is less than 0. So less than 0 means can be positively concave upward, can be negatively concave downward. Can be positively concave downward or negatively concave downward. If you want to differentiate, then you have to look at the dy dx. If dy dx is decreasing, then decreasing concave downward. If the dy dx is increasing, then increasing concave downward. So the other 4 jenis. So now we go to here. Why we study concave upward downward? Because the change of concavity. Concavity means maybe concave upward, maybe concave downward. So the change of concave outward of a function can be used to determine the point of inflection. So that's why we study in concave upward downward, because we are going to identify which point is inflection point of inflection. So what is point of inflection? So if a function is continuous, same like just now, if you want to identify the point of inflection, the syarat is the function must be continuous. Okay, at the point. If it is not continuous, though, dia bukan. If the function is continuous, the concavity changes from upward to downward or from downward to upward at a point, then the point is called point of inflection. If got changes, then that is a point of inflection. Either from upward to downward or from downward to upward. Okay, because point of inflection only got one type only, but maximum point, minimum got but 2 types. So maximum point is from changing from increase to decrease maximum, decrease to increase minimum. But point of inflection cuma ada satu jenis saja. So we don't care whether the thing change from upward to downward or downward to upwards. Both are considered as inflection point. Okay. So how to see by using diagram, how to identify? Okay, let's say concave. This one is concave downward. This one is concave upwards. So let's say I have a concave downward and concave upward. Let's say I draw a graph. Okay, I draw a graph. The graph is like this. So when you identify this one, this up to here, this is concave downward. Then at this point, the graph change becomes concave upward. So this point of changes, okay, the graph change from concave downward, then to concave upward. So here, this is the point where the connection between downward and upward. So this is the point of inflection. So point of inflection, you have two types. One is stationary, one is non-stationary. Non-stationary means the connection is directly like that. Stationary, you means what is the meaning of stationary? Stationary means it is a horizontal line. Later, I'll let you see what is the meaning of stationary. At this point, means you see the connection directly, very smooth. The line of the curve very smooth going down. Then this is non-stationary point of inflection. Point of inflection means the connection between concave downward to concave upward. Okay, now we go to the second type. Okay, now, just now, concave downward can be the whole mangkok. Concave upward also can be the whole mangkok, but we still can separate. Concave downward, you can separate on the left hand side, right hand side. Okay, increasing, concave downward, decreasing, concave downward. Concave upward also you can separate, increase, decreasing, concave upward, increasing, concave upward. Okay, just now I use the whole bowl, but now let's say I use sparrow. Okay, this one only. This one, increasing concave downward. This is increasing concave downward. Then at this point, suddenly change to increasing concave upward. Both are increasing, but this one is downward. Come from here. Then you see, the connection is here. So this is concave downward, change to concave upwards. So the point of connection, it is here. So this kind of point, you see, when they do the connection here, this point is dekat sini. Okay, this is the stationary point, yes or not? Because when you turn the U shape, this is stationary point. When the connection is at the stationary point here, so this is the stationary point of inflection. Just now, the connection is at here, what? This point, what? Just now the example. Okay, this is not stationary point. Okay, we'll go back to just now. Okay, the connection, you see, the connection is this point. This is not stationary, this is stationary point, okay? So the connection is at this one. So that's why you call it a non-stationary inflection point. Whereas this one, the connection is at here, the stationary point. So that's why this kind of inflection, also inflection, but it is stationary inflection point. Inflection point got two kinds. One is stationary, one is non-stationary. So when you sketch the graph later on, when you come to the part of sketching graph, when you sketch the graph of stationary inflection point, you have to show a club like that. Macam ada satu club like that. When you sketch the inflection point of non-stationary, you directly go up. No club. And that is a bit different. Okay, now I'll show you another example. Okay, just now I use the positive concave downward and positive concave upward. Positive and positive, you cannot join positive and negative. For example, okay, when positive, how do you go and join the negative here? Macam tak smooth. You see not? So normally positive join will positive, negative join will negative. Okay, let's say this one. It is negative downward. Then we'll join with negative upwards. You see that? So the brown color, if you join with green color, macam tak smooth. You see? Macam mana? Okay, so a negative will always join with negative. So this is negative downward. This is negative upward. Okay, so downward change to upward. Okay, and the connection is here. So you don't have cloak here. So the point of connection is this one. This is not stationary point. So that's why we call it a non-stationary point of inflection. Okay, then another example. Okay, just now was downward change to upward. So now this one upward change downward. This is the connection point at the end here. So this one is upward change to downward at this point. So this is non-stationary point of inflection. Okay, here I'm using the whole mangkok. Now let's say I don't use the whole mangkok. I use 1/4. Okay, so this one. Negative, remember negative with negative. Okay, upward, initially is upward. Then change to downward. Then this is the connection point. So this connection point is the bahagian ini dengan bahagian ini. This is stationary. So when you see here got a macam S shape, the point of connection got macam a cloak like that. So this kind of connection, so we call it as stationary point of inflection. Okay, another example is this one. Upward, change to downward, but positive upward, positive downward. So this is the connection. So the connection this one is not stationary. Stationary dekat sini. So you see, you don't have any cloak here. Just directly like a straight line like this, very smooth. So this is non-stationary inflection point. Okay, you see, the syarat of inflection point is they must be continuous. Okay, for example, if the point is nanti dulu. Okay, come to, let's say I have a curve like this. Okay, let's say you have a graph in this shape. Please identify how many inflection points. How many inflection points? Termasuk stationary and termasuk non-stationary. Please calculate and let me know how many inflection points. Include 5. Tengok bye-bye oh.
7.
Jangan teka saja. How many inflection points?
6.
7, 8, 9, 10. Okay, you take the pen and point out. Where is the inflection point? Someone please volunteer. Or you can more than one come in also can. Okay. Kenapa hilang? Someone. Oh, you cannot draw. Can you draw or not? Can you draw? Yeah. Okay. Someone? Any more? Yes, correct. The first one is correct. Okay, good. What bulat besar-besar? This one not clear. You make like siapa ni? Buat you punya bulat. Any more? Yes, correct. Ada lagi? Who was that? What are you doing? Ada lagi? How many? 1, 2, 3, 4, 5, 6. Ada lagi? Okay. Which one is non-stationary? You make a pangka. Di tepi bulat itu. Pangka for non-stationary. Non-stationary. You make a cross beside the dot to tell me that that one is non-stationary. Okay. Oh, yes. Ada lagi? Yes. Yes. Oh, right. Yes, good. Okay, the other two. Stationary. Use a tick. Right. Stationary. Yes, correct. Okay. So that is the one. So how do you identify from the diagram that is inflection point? Okay, so we go back to the slide. Okay, that is the one. Okay. 1, 2, 3, 4, 5, 6. Okay. All right. So we go to the next slide. Okay. So next slide, remember, if you want to identify concave upward downward, must be continuous. If not continuous, for example, this one, even though this one is concave upward, this one is concave downward, the graph change from concave downward to upward, but this is not inflection point because this is not continuous. Okay, so continuous is the syarat for maximum point, minimum point, and also point of inflection. Okay, not continuous. So this one is not inflection point. Okay, so I finished. Now go back to the. Okay, this is the one. Okay, now for example, for the following function, determine the interval in which the function is concave upward and concave downward. Hence, okay, so first to this question never go through maximum point, minimum point directly. You are asked to find inflection point. So inflection point you need double prime. So first you go to first prime, then double prime. You get this one. Okay. Normally during the examination you are asked to find maximum point, minimum point also. Then barulah pergi ke inflection point. But this one without going through the maximum point, minimum point. Now directly you go to double prime because you want inflection point. We are not interested in maximum point, minimum point. So once you get double prime, you get 12x minus 6. So since now you want to concave upward, then you make it equal to greater than 0. So greater than 0, you find that x is greater than 1 over 2. So means here you give then you give conclusion lah. Yeah. So therefore the interval of concave upward is this one. Okay. Then for concave downward also the same thing. You have to rewrite the working step. So when fx concave downward, this one less than 0, we calculate x less than 0.5, then the interval is this one. Then there's no problem. Then hence means you are going to use this interval to determine the point of inflection. So you susun macam tadi. Okay, the first interval is this one. Equal susunan. Please do not use 0.5 up to infinity on the left hand side. You follow the number line. Okay, then after that you compare the slope of the double prime. So you're interested at inflection point only. You are not interested at whether it is negative inflection or positive inflection. Positive inflection, negative inflection, that one is when we sketch the graph, and then we have to know. But now you are not interested in sketching graph. You just want to identify the point of inflection. So just slightly N shape. So for this for this interval less than 0.5, it is concave downward. Okay, then the curve is N shape. For this one, concave upward, the curve is going up. Okay, so you see at this point, x is 0.5, the graph changed from downward to upward. So give reason. In your module, I didn't give reason. So you better give reason. So the reason is, since the functions change from concave downward to concave outward, okay, from concave downward to concave upward, then this point. So that's why you need to calculate the y, because you want to mention the coordinate point. So that's why this point is a point of inflection. Give the reason. Okay, so this is by using calculation without using graph. Just now was using based on the graph without calculation. This one is by using calculation without graph. Okay, B, okay, same thing, you want to identify the point of inflection. So same thing, you differentiate 2 times, you get 2, no x, means 2 is always greater than 0. 2 is always greater than 0. So means this function is always greater than 0, means always concave upward. So fx concave upwards for all values of x. So means we don't have any changes of concave upward, downward. If no changes, means no inflection point. Okay? You must have changes either from upward to downward or downward to upward. Then the point inflection. If no changes, let's say the before the point, it is concave downward. After the point, also concave downward. So means it is not an inflection point. Okay. Up to here, anything you want to ask? So I do conclusion. I'm going to stop here. Okay. Today we learn how to find maximum point, minimum point by using increasing, decreasing interval, and how to find inflection point by using concave upward and concave downward interval. So now then you go back, you do the exercise 8.8 and 8.9. So if you don't have anything, then you can leave. Okay, thank you, class.
Thank you, teacher.
Thank you, teacher.
Okay.
Teacher.
Yes, thank you.